So the next topic is fundamental theorem. Fundamental theorem of arithmetic. Before explain the fundamental theorem of arithmetic, I want to explain you the prime numbers and the composite numbers. So prime numbers means the number which is divisible by 1 and itself. In other way, we can say that the prime number is that number which has factors 1 and itself. Means there is no more than 2 factors as 2. So it is divisible by 1 and 2 also. 3, this is 1 and 3 also. 5, 1 and 5 also. So these are the prime numbers. And 2 is the least prime number. 2 is the least prime number. And 2 is only one even prime number. So 2 is the least prime number and 2 is also an even number. Now composite number. Except these numbers means and except prime numbers, other numbers are composite numbers. As we can say that a number which is divisible by 1 itself and at least one other number, then the number is called composite number. Otherwise, it is not a composite number. In other way, we can say that if a number has more than 2 factors, then it is called composite numbers. As 4. So 4 is divisible by 1, 2 and itself 4. So 4 is divisible by 1 and itself, except 1 and itself, it is also divisible by 2. Means 4 has more than 2 factors. 4 has more than 2 factors. Suppose 6. So 6 is divisible by 1, 6 as well as by 2 and 3. So 6 has more factors except 1 and 6 itself. Means 6 is also divisible by 2 and 3. So the number which has more than 2 factors is called composite numbers. So this fundamental theorem is depend upon composite number. Means this fundamental theorem is based on composite numbers. So if we suppose that we take 12 and we find prime factors of it, so we can write it as 1 into 2 into 2 into 3. So we can't count 1. So we can write 12 as 2 to the power 2 into 3. Same as, suppose that 18. So we can write 18 as 2 into 3, 6 into 3, 18. So we can write as 2 into 3 to the power 2, 3 square. So fundamental theorem states that any composite number can be expressed or can be written as a product of primes number. Product of primes number. Their order does not have matter. Means their order has no value. We can write this as 3 into 2 square or 3 square into 2. So order doesn't means, but 12 is always written as 2 square into 3. Means 12 is written as the factor of prime numbers. Factors, prime numbers and product of prime numbers. So the fundamental theorem states that every composite number can be expressed as a product of primes, and this factorization is unique. Means 2 square into 3 is unique. Means always 2 square into 3 is represents 12. And 2 square into 3 cannot express except 12. Means 2 square into 3 cannot express other numbers except 12. So, and this factorization is unique apart from the order in which the prime factors occur. So, there means this order of prime factors doesn't matter. Means we can write it as 3 into 2 square, so it doesn't matter. We can write it as 3 square into 2, it doesn't matter. So, the fundamental theorem of arithmetic states that every composite number can be expressed as a product of primes, and this factorization is unique, and their order in which prime factors occur doesn't matter. It means the prime factorization of a natural number is unique except for the order of its factors. So this is fundamental theorem, and we can express every composite number as a product of prime numbers.